This is video 4 for Computer Science 3344. Hot on the heels of video 3, we just now saw a grammar, a context-free grammar for arithmetic expressions, which was bad. Why was it bad? Well, it was ambiguous. There was more than one way to generate exactly the same arithmetic expression, and we don't want that. So example 5 offers hope. Example 5 is actually a fix to example 4. Still context-free grammar, still arithmetic expressions with pluses and timeses and stuff, but it's going to look like this. E goes to E plus T, or just T. T goes to T times F, or just F. F goes to parentheses E, or A, where A in the parentheses and the plus and the times, by assumption, those are all of our terminal symbols. This is a big deal. It looks like a fairly simple grammar. It's a little more complicated than the one before, but this is so important. I'm going to put this in a box. This is like the standard grammar for generating arithmetic expressions, believe it or not. I'll sometimes recite this in my sleep, during my dreams. We had to know this for a qualifying exam for PhD way back in the early 80s. Okay, enough of a side trip. Let's see why it is so good, if we can even make the case for that. Let's derive, using this, the string that gave us so many problems in our last video, which I believe was A times A plus A. I think that's what it was. And away we go. Here's capital E. Capital E. Now it looks like I could get the times sign or the plus sign, either one, first, just like I did last time. But look at this. Suppose I want the times sign first. Then I'm going to have to make a beeline for the times sign, replacing E with T and then T with T star F. There's a problem with that, though. If I do that, there's no way for me to get back up here and add in the plus sign. It's going to force me to keep going forward, and I'm not going to be able to jump back up here and get a plus sign unless I put parentheses, and there are no parentheses in that expression. Oh no! On the other hand, if I decide the plus sign goes in there first, then I still got plenty of time to get to the times. Is that true? Let's find out. Let's do the plus sign first. E goes to E plus T. Leftmost derivation, dims the rules. Got to replace that E with something. Now I can get the times sign, T star F plus T. Got to replace the T. Leftmost derivation. I'm going to quit saying that. T, I actually want that to be an A, but I got to replace it with an F first. F times F plus T. Now I got to replace that F, and it looks like we're ready to come in for a landing here, huh? I got to replace the F. I'm going to do that one fell swoop for both of those, which I can get away with. I'm using identically the same production rule. Replacing F with A twice, I'll get A times A plus T. Now I got to replace the T. Even though it's way at the end, it's our leftmost and only non-terminal left. When I replace the T, I replace that with an F. A times A plus F. Finally, and mercifully, I can replace the F with an A, and voila, A times A plus A. Now, it's kind of sort of beyond the scope of this course, but I do try to mix in answers to the question, why do we have to know this? Well, if we go backwards again, as I did in the last video, if we go backwards again, where these things collapse corresponds to when that part of the evaluation of this arithmetic expression is going to have to be done by the compiler. The compiler, bless its heart, regardless of how complicated your arithmetic expression is, it's got to split that up. You know some assembly language by now, you're seniors, right? It's got to split that up where there's at most 2 operands involved in each operation. A plus B, A times B, A minus B. There ain't no parentheses and big complicated expressions in a similar language. It's just 2 register values, 2 numbers at a time. And where these collapse is where I take those 2 operands and apply that operator. Here we go. collapse them. Well, they don't collapse for a while, do they? The first thing to collapse is the time sign. That's good. Multiplication should be done before addition. So that t star f collapses into the e, and then we've only got two operands here, e plus t, that collapses into the value of the entire expression. So built into this, sort of subtly, I suppose, going backwards from the actual arithmetic expression, we end up with a single token, a single symbol that represents the value of that entire expression. And it doesn't matter how complicated this gets. I could have used this grammar and generated something a lot more complicated, such as, what if I do want the addition done first? That makes a good question, doesn't it? What if we do want addition first? Well, the answer to this is the same as it would be in a C or a C++ class. Use parentheses. Duh. Billie Eilish reference. Parentheses, exclamation point, to cover up the possible misspelling. Use parentheses. So somehow or another, I've got to crank out some parentheses around that a plus a. Let's just, well, what would that look like? We want this, a times a plus a with parentheses around that part. A times a plus a? Does that seem right? Well, away we go. E, you know what? I should have done this beforehand. Let's work on this together as a class. The time sign first. Oh, what about my plus? Oh, well, I got to get the time sign first. E goes to t. Leftmost derivation. Replace t with, there's a time sign, t star f. Got to replace the t. T here gets to be replaced with f. Now, even though I got two f's, I'm not going to do that little shortcut trick of putting a 2 over here, because I don't want to replace both of these f's with the same thing, looking ahead just a little bit. This f, that's the expression I'm headed toward, that f is ready to become an a times, and I'll leave that f alone for now. But now it's the leftmost and only non-terminal. I've got to replace that. Look what we got here, though. There's where the parentheses come in. One of these things can expand out and be an arithmetic expression in its own right, all contained inside parentheses. And nested parentheses even. I could generate sets of parentheses till the cows come home if I want to with this. Recursively. Bad word. Times f replaced by parentheses e. The parentheses are there to stay. Remember, those are terminal symbols. So now it's a times parenthesis. And here's where the plus sign comes in. E plus t. Replace the e. A times, well, I want to get to the a. Man, that a is a long way from here. E, replace that with t, plus t. And I bet I can replace both of those. Yeah. There's a shorthand. Twice replace t with f. And we finish with a multiple replacement flourish. Those are underlined F's. Those are not E's. Underline F. Replace each of those with A's. And finally and mercifully, we have our expression, A times A plus A. Ta-da! Now, that, I didn't really have any choices, except for whether or not to take a shortcut. And that's not really a choice. That's just kind of compacting what the derivation looks like. This leftmost derivation of that arithmetic expression is unique. Let's go backwards. What's the first operator to disappear? Up, lots of symbols, lots of symbols. Oh, look, the first thing to go away is that plus. The compiler is going to translate that into something plus something else, and that's the first part of this expression that will be evaluated. What's the next thing to disappear? The time sign. Multiply this left-hand piece by whatever the value of that parenthetical expression turned out to be. and we could generate all mean of complicated arithmetic expressions using this. Any number of them. Fortunately, we don't have a lot of time. We do have time, though. The old clock on the wall, yeah, this is only 10 minutes. 10 minutes is nothing in this class. We can talk for hours, can't we? I'm going to partition off a chunk of the board again. That's going to be the new normal in this class, I bet you. This was example 5. What we haven't done, you know what? There I go again. It popped in my head. Were there questions about this before we continue? I hope not. Example 6, this is the first one that we'll do from a description. And by that I mean, up to this point, I believe we just kind of plopped the grammar on there and said, what does this make? So here, we'll start with the description, see if we can come up with the grammar. The description is this: strings of zeros and ones that have at least 2 zeros. And you have to say it like that. At least 2 zeros. You got that language all visualized and pictured in your mind? Well, it could be easier. Here's the start symbol. S goes to, you know what? You got to have 2 zeros. Just get them out of the way. 0, 0. We don't want to stop there. A. I'll introduce another non-terminal. And as long as I got the 2 zeros, I don't really care what A is. It could be anything. 0 and then another A, so I can have as many zeros as I want. Or I can alternate with ones. 1A or epsilon. There we go. Strings of zeros and ones that have at least 2 zeros. And I believe this fits the bill, doesn't it? That's going to have at least 2 zeros. We guaranteed that right at the beginning. This is like a wildcard character almost. It's like a star. I can replace A with a 0 and keep going. I can replace A with a 1 and keep going. Or I can call the whole thing to a halt and put an epsilon. You're going to have to realize that in cyberspace, nobody can hear you scream. I know that's wrong. You know that's wrong. The American people know that's wrong. This is a subset of the language that we want, but it's not the entire language. We don't want to make this overly restrictive. This requires that the 2 zeros that are required have to show up at the very beginning. There is nothing in the description that says that. It's an easy fix, though, right? Instead of that, we can just say S goes to, and since this is a wild card, I can have a wild card up front, and then my 2 zeros, and then another wild card. Yeah, we've seen stuff like that before. And that's even allowed. In a context-free grammar, that's allowed. It's not. You know what? Just because it's allowed doesn't mean it's a good idea. And it's not right either. This is going to require that the 2 zeros come together. Maybe that was a second attempt, but we did that just as we were thinking deep thoughts and considering how we might want to write this grammar. This is kind of like a wild card up front, a wild card at the end. These are strings that contain the string 0, 0, which unfortunately, yet again, is not the set of all strings that have at least 2 zeros. So we have to put our thinking caps on and get a little bit creative. If you take my word for it that this kind of represents anything goes, this generates any string of zeros and ones, or just the empty string itself, we still got to work on this start symbol here. How about this? I'll even write this big. This will be the grand finale. S goes to, well, I don't even care what it starts with. A for anything. I just now thought of that. A for anything. Here's a required 0. I'll stick that in there. Does the next 0 have to come immediately after it? Absolutely not. I could have anything in there, including the empty string. Maybe the 2 required zeros are right next to each other. Maybe they're the only things in the entire string. Here's the second required 0, and then that can be followed by anything. See, don't you wish I had listened to you 15 minutes ago? You already had that in mind. So here's the grammar we end up with. Perhaps with some unnecessary belabored trial and error and unnecessary insults to your intelligence. But let's think about this again. Here's the start symbol. I've got these in the wrong order. So I'm going to have to designate the S is the start symbol. It says anything goes, then there's a 0. Anything goes, then there's another 0, then anything goes. Why am I making such a big deal out of this? Because you really have to read the description of the language carefully to make sure, a couple of things. To make sure you didn't accidentally introduce new strings that weren't in that language. I don't think that was the problem with these. The other thing you got to make sure is you can actually generate all of the strings that are in the language. That's where these 2 initial failed attempts failed. They generated subsets of this, but they didn't generate the whole thing. Why? Why would I make such a big deal out of this? Because I want you to think about it that hard when you do the homework that's attached to this email. End of example 6. End of video 4. I'll see you online.